Okay, welcome to Aerospace Studies 200, Science of Flight. We're on Chapter 2, is that right? Chapter 2, Lesson 1, and we're covering the atmosphere. It's page 112 in your book. What I'd like to do first of all is to go over a history lesson. As we can see here. How many people have ever heard of the most expensive plane, actually the most expensive stamp in the world? Okay, it's this one right here. It's called the inverted Jenny. And this stamp right down here at the bottom, we see it up there? Yep. This stamp, can you see anything unusual about it? Good to say, what's unusual about that stamp? Let me zoom it up a little bit. Can I zoom it? Look at that stamp. What's unusual about that stamp?
It looks old.
It looks old. Yes.
It's the Washington House.
It's the Washington House.
It's upside down.
The plane is upside down. The plane is upside downwards. It's called a JN4 Curtiss plane, 1918. It was an airmail stamp. They were inventing airmail. And it's called the inverted Jenny is the name of it. 4 of these sold for almost $1 million. No, total, 4. One of them sold for $300,000. There were only 100 ever presented, and it was the most famous stamp, collectible stamp ever. And it was when we were first inventing airmail, 1918. Woodrow Wilson. Let's see if I can zoom back out here. Woodrow Wilson, you can see a picture of the president here, was at the launch of it. And actually it's an interesting story about Major, let's see, what was the guy's name? I don't want to get the wrong one. Woodrow Wilson, the first airmail was done by Major Fleet. And he selected this Lieutenant Boyle, Lieutenant George Boyle. And he took off for the first airmail flight, supposed to go from Washington, D.C. to New York to Philadelphia. He got lost, and he ran out of gas and crashed. Bummer, okay? Think about flying in one of those planes. You see this plane right here? Think about flying this plane, not knowing the weather besides looking at the end of the field. And so he came back and tried again. And if you know where to go from Washington to New York to Philadelphia, that is north, okay? He flew due east and got lost to the Chesapeake Bay and crashed again. He ran out of fuel, landed on the eastern shore, was thrown out of the Army pilot service, and the conclusion had been reached that in the best interest of the service required that Lieutenant Boyle be relieved from his duty. Other pilots, the same day, made their trip successfully. And so it was pretty interesting that this very famous stamp that was inverted, the most collectible, commemorated the terrible beginning of airmail in America. And the guy also did not know how to judge the weather and find out what was going on. So I thought that was kind of interesting. I got that in my AOPA, my Airline Pilots Association magazine this week. We're starting to talk about atmosphere. The atmosphere. This is the objectives for the first lesson. Learning about the terms of the atmosphere, the roles of water, and the primary causes for your atmospheric motion. I'll tell you guys right now, at the beginning of this chapter, this is what we're covering this entire quarter for our Aerospace Science of Flight. The whole purpose of this is for you to be able to know when you fly, when you travel, why the weather works the way it does. Here is a question that my children actually asked me. Why does the wind blow? What's the question? Why does the wind blow? Cadet Van Boeven?
Because
Big
warm
coat.
air and cold air mix.
Hot air and cold air mix. That is close. Hot air and cold air mix. Does that mean the wind never blows on the North Pole?
No.
It's all cold. Where's the hot air on the North Pole? Why does the wind blow? Is it that hard? Come on, you guys are college kids.
I think it has to do with pressure, and it wants like a certain temperature of air wants to go into one area, so that's
Pressure and certain temperatures there. So if I walk outside, well, today, isn't the wind blowing today? So they have different pressure systems. Cadet Buell, why do you think the wind blows? Why do we have pressure systems?
Because hot air and cold air push off.
Hot. I keep hearing you guys coming back to hot air and cold air. Well, what causes the cold air? Well, why?
Water in the air, sir?
Water in there. Yesterday in Arizona, it was 4% humidity. Does the wind not blow in Arizona? It blows, but it's 0.4%. Does it only blow on the East Coast where it's really humid? Why does the wind blow? This is not hard, guys. I'm just kidding. It is hard. But that's why I'm teaching this course. But I'm telling you, it's a kind of a ROTC joke that if you take my Science of Flight class, this is the one thing you have to learn about weather. The wind blows because of the unequal heating of the Earth's surface. Everybody say that. The wind blows because of the unequal heating of the Earth's surface. All righty. So, today, as an introductory for your entire weather class, and you learning about the atmosphere, I want you to think about the unequal heating of the Earth's surface. And in particular, an easy way to do this is to think about the ocean, which, you know, kids in Arizona, some of you may not have ever been to the ocean, but the big concept is this is land, and this is water. And let's say this is in California, and the weather gets up to be 90 degrees. And one day, what is going to heat up quicker, land or water? Water?
No land.
3/4 of the Earth's surface is going to heat up more than the beach of San Diego?
No.
So in general, land will heat up quicker because the Earth is reflecting off the white sands of the beach. So in the morning, when the land is heating up, the breezes come from the water to the land. And these are called seaward breezes because the air here is heating up and this is getting hot. Okay? What happens in the afternoon at sunset? What cools off quicker?
Land.
So where does the breeze go? Yeah. Sea breezes. Okay? That's a God's eye view of it. This is very, very simple. And so therefore, if you're sitting out at the ocean, and this is the land, and this is the ocean, in the morning, in the day, which way is the wind blowing? Towards the land, right? Because all the heat here is rising. This is what happens on every beach in every country, especially on California. Because what temperature is the water in California? Cold. I mean chilly willy, okay? I mean real cold because of the circulation of the ocean and the fact that the water in California generally comes down from Alaska, right? It's cold. Compared to the Atlantic Ocean, where all that water in South Carolina, Florida, North Carolina, Virginia, where does that water come from? The Caribbean, the Gulf Stream. It comes heated up in the bathtub of the Caribbean, and the water comes right up the East Coast, and it is really warm here. Excuse me?
I thought the Atlantic was colder than the Pacific.
Thank you very much. Try again. No, in general, the coast of America, the Pacific is really, really cold, and in general, the Atlantic is much, much more warmer. Go look at it online. Just as you've never been there. You could, I would swim in January, February in Atlantic without any, wetsuit. Where were wetsuits invented? California. They were invented in Florida because you don't need them. Yes, sir.
I was saying they were invented in California.
There you go. Invented in California for surfers. So anyway, hold it. Why do we have wind?
Because uneven heating of the surface.
So the question was, in the Arctic Ocean, or the Arctic, the South Pole, do we have winds?
Yes.
But it's all cold. It's all cold. How can we have wind when it's all cold?
Uneven heating.
Because of the uneven heating of the Earth's surface, right. You actually have water next to land, and even though the land is frozen, the water's a different temperature, the sun's going to reflect off the snow, and it's going to elevate the hot air is going to rise, and even that situation, same thing in the Saharan desert. It's 110 degrees, everything's 110 degrees, but even the small heating of the Earth's surface differently, that causes your winds, okay? That is the big thing to learn when we're studying all about the atmosphere. Here are some of the words you need to learn. They're on page 113. They deal with the different parts of the atmosphere. I assume that most of you guys have heard of the word troposphere or mesosphere, the different parts of the atmosphere. This is just reminding you, in general, that vocabulary list there on page 113 is your test, which you guys will be taking in 3 weeks. And so I expect you to review those and get to know these. Here's a question. When we're sitting here breathing right now, what percent of the air is oxygen?
21.
So, what happens when you breathe 15% oxygen? You pass out. Okay, that's not good. Can we breathe more oxygen than this?
Yeah.
No? Yes?
Yes.
In general, no. But what about scuba divers?
They don't breathe oxygen. Breathe oxygen.
When you're a scuba diver, you don't breathe oxygen. Oh, at depths. There are what I'm saying is recreational divers, which I do dive. I dove this last weekend. I breathe this exact combination, but there is a more complicated way of breathing. It's called enriched nitrogen, nitrox, and basically you breathe a higher percentage of oxygen so that you don't get as much nitrogen. Nitrogen in your blood is bad with scuba diving because it can kill you. It'll make your joints hurt. It gives you heart attacks, headaches, strokes. It's bad stuff. So when you scuba dive, that's what you're trained to do, is learn to control your oxygen intake. Yes, sir?
It's called the bends.
That's true, exactly. How about here in Arizona? What's the highest point in Arizona?
13,000.
Where? You can look at it right at our back door, right? Today, when you're looking for the International Space Station, Humphreys Peak is to the northeast. You're going to be looking to the left for the space station to appear. But the highest point in Arizona, you can see from Prescott High School, from my house. If you walk up to the top of that, what are you subject, or what kind of physiological problems may you have?
Dizziness.
Dizziness, why?
Because you're getting higher up in elevation, so the oxygen will become thinner.
Ding, 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 ding. Give me air 5. Good job. That was perfect. That's exactly right. At the highest point in Arizona, you may get hypoxic, is the term. And we will be covering that later on in the Science of Flight class. And that is something you do have to worry about when you fly, is hypoxia. Excellent. Basically, the atmosphere. Let me ask a question. And again, this goes sort of towards my space class. Is the Earth rare?
Yeah.
When I was a kid, guys, there was no thought that there was any other Earths around, because we did not know of any other planets circling any other stars out there, any other suns out there. Now we have discovered 2,000 or 3,000 other planets circling other suns out there. out of those 2,000 or 3,000, we have not found any that have an atmosphere like us. We don't have any with oceans of water. And so, are we rare? Well, there's other planets, certainly other suns out there, but we're kind of rare in that we haven't found this yet. Maybe in your lifetime, with different technologies, different telescopes, we may be able to do that. Yes, sir?
They actually, I read this in an article, and it was a credited article actually. It was that Neptune actually had seas of oceans, but they were just covered by a giant blanket of ice.
I think it was the Neptune's moon, Io, and there's actually a proposal to send a probe there to break through the frozen surface. That's true. The troposphere, Tropopause, these are unusual. We have no other proof in the universe that they have these type of areas that actually protect the Earth's surface from all these sun rays. So if you lived on Mars, or you lived on Neptune, you'd be zapped. Mars has incredible differences in temperature, same thing as the moon. They do not have our atmosphere. They don't have rain there because it does not have troposphere, tropopause. What is the stratosphere? How high is the stratosphere, guys? It is very high, and it goes up to the 50 kilometers. How many miles is 50 kilometers?
Or is it?
How many kilometers are in a mile,
I thought it was
guys?
5. No, I'm wrong.
You're really wrong.
Yeah.
Isn't it like 30 miles?
Ding, 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 ding. You saw that? Yay! Okay, so 1 kilometer equals 0.6 miles. Okay, so 50 kilometers equal about 30 miles. So 30 miles high. Do we fly up into the stratosphere? Can you fly there in a plane?
No.
Not a passenger plane? So 30 miles, how many feet is that?
A lot.
A lot. Good answer. It's about 5,000 feet per mile, right? 5,280
5,280.
or 6,000 feet when you're talking about nautical miles. So 5,000 times that is about 150,000 feet. What does the normal airliner fly at?
30 to 50.
30 to 40,000 feet, right? So no, we don't go up into the stratosphere very much at all. It is very dry. The ozone layer. What is the ozone layer? What's an ozone layer? You guys should know this. What is an ozone layer? Yes.
It's a layer of gas that protects us from ultraviolet radiation.
You're exactly right. Give me air 5. Good job. That is exactly right. And that protects us from being zapped. Right now, we do not know of any other moon or planet that has an ozone layer to protect its inhabitants from the ultraviolet rays. Mesopause. Mesosphere. This is above the stratosphere. This is where things get really cold. This is where things get really cold, minus 90 degrees. We can't exist up there, okay? When they're actually in the space station and moving up into the stratosphere, they have to be very, very cold. The upper atmosphere, Tropopause, thermosphere. Things start to get very hot, 1,800 degrees. So you can think about the International Space Station, think about all the different temperatures that the International Space Station undergoes, or astronauts, or the missions to the moon. You can imagine what kind of engineering problem it is to go from as hot as we're here on Earth to as cold as it was in the mesosphere, and then up to the thermosphere. Here's a question: atmospheric pressure. How much does atmospheric pressure change? How much does temperature change? Okay, if we're at 6,000 feet in Prescott, how high is Phoenix above sea level?
3,000.
1,700, about 2,000 feet. Is it colder in Prescott or is it warmer in Prescott from Phoenix?
Colder.
Why?
It's higher up.
It's colder because we're closer to the sun. I kind of like that.
Best stories ever.
The correct answer is it's about 2.5 degrees per 1,000 feet. So if we are about 3,000 or 4,000 feet above Phoenix, in general, the correct answer is it's about 10 degrees always colder here. Purely because of the elevation. Maybe because of the unequal heating of the Earth's surface and the winds, things may change. But in general, we're about 10 degrees cooler. So in general, have you ever heard of the temperature here going over 100 degrees?
Once.
Rare. Does it ever go over 100 degrees in Phoenix?
A lot.
Like 100 straight days, right? 92 straight days. But why does it not go over 100 degrees here?
Because
Because
of
of
elevation.
If it's 120 degrees in Phoenix, which it does rarely happen, it may be over 100 degrees here, but it's rare. And so that's why people love Prescott. Yes?
I've actually been in Phoenix when it got up to 120 degrees. Not fun.
It's not fun. I actually flew in Phoenix when it was the hottest degree ever, 126. I flew on that day. I flew a fighter. And it was interesting. Nobody else was flying. All the commercial airlines were shut down because they did not have the proper weight and balance and takeoff data for above 120. So it was very interesting. Okay, bottom line, this is telling you that why does the wind blow? Why does the wind blow?
The uneven.
Okay, so why are there different pressure systems in the world?
Different elevation.
Different elevation and different heating of the Earth's surface. Why are there fronts in the world? Different unequal heating of the Earth's surface. You're going to laugh, but this is exactly what you had. Okay, you have high pressure and low pressure. In general, you need to know that low pressure, let me ask a question. Does low pressure good weather or bad weather?
Bad.
Bad weather, correct. High pressure is generally good weather. That sounds great. We will stop that today. Yeehaw! And we will pick up this tomorrow.